Hello and welcome to my final project presentation. My name is Katie Muldoon. Okay, so this project's going to be about the MBTI, which is the Myers-Briggs type indicator. So Myers-Briggs personality types are the four character sequences that generally try and attempt to tell you something about how you act as a person and your various tendencies and leanings. So it's like INTJ, ENFP. You've probably taken a quiz like on BuzzFeed or in like middle school or something having to do with this. So let's get into it. The data. The original data set that I downloaded was from Kaggle. So each entry has a Myers-Briggs type indicator, which is the four character item in the leftmost column. And then it had one long string of concatenated social media posts. So for each person, it has their type and the last X social media posts they've made over a certain period of time. I'm not entirely sure how long that period of time was, but I'm certain that each post has at least the most recent 20 posts. So, the initial exploration with this data. So initially all I had were the type and the post, and so there was not much I could see from there, but I decided to make a bar graph of how many, or of the frequency of all the types. So if you look at the graph, it shows it's definitely not a uniform distribution, definitely a lot more introvert personality types than extrovert. Also definitely a lot more prevalent the N personality type, which is the intuitive leaning. A lot of the ES and IS are not heavily represented, so I'm guessing that it's going to be really hard for my model to pin people into those categories, because if they're less represented than in the training set, it's definitely not going to tend to mark people correctly as that, but that's something that we'll see later on. I also decided to add dummy codes for presence of each letter. So basically, the way that these work is you either have an I or an E as the first one, you either have an N or an S as the second one, either a T or an F as the last one, or a J or a P as as the very last one. So it's an either or situation. So I wanted to see if there was a prevalence between any of these characters, and it didn't look like there was an overwhelming correlation between any of them. The most correlated would be J and I, but still at 0.16, it's very low, so I wasn't inclined to say that there was any correlation that screamed out at me or needed to be accounted for. So I derived new features from my text parsing, the number of exclamation points and periods per post, the number of links per post, and the average length of each post. I thought that these were things that outlined social or personality indicators in people, and I thought that they would be good features to try and start a simple analysis on. I would have liked to add something a little more qualitative, like word complexity score and number of adjectives, but I couldn't get the API to work in time. This is how I went about separating and deriving the features. I used a regular expression, and I used a couple of helper functions to delimit and count the occurrences of objects in the original post data frame. And then I decided to store the original data. I loaded into a data frame in my R Markdown file, and then all of the derived features, such as average length and average number of links per post and all that, were stored in a collection in a Mongo database. So my plan of analysis is I'm going to make a couple different models. I'm going to try and categorize people based on their social media posts all in conjunction, so by 4 character increments, so either as INTJ, ENFP, etc. And then I'm going to make a couple of different models and try and guess their single character presence. So that might make more sense as we go on. And I'm going to use a logistic regression, KNN, and it says naive Bayes, but I really meant to say decision tree, and then analyze what that means. Okay, the models. So my first model was a logistic regression model. So I created logistic regression for each of the variables. So the dummy codes that I created were whether or not I was present, N was present, T was present, J was present. Since it's an either or situation, I thought that this made sense. So I started off initially with all of the dummy codes to every feature, but then turned out that some of the features were not statistically significant, so I just removed the ones that were not statistically significant until I was only left with an effective formula, so as to avoid overfitting. This yielded okay results. I and N were easier to place than T and J, but that's a theme that we run into throughout our models. So I was overall happy with this model. It's not the best, but it's not the worst. It was better than randomly assigning, so I figured that's a good starting point. Oops. Okay. Next up, I did K and N, and I ran the K and N one by one, so on the I, N, T, and J. This one, I did the demicode to all of the variables. This one was great. It had a really high score for I and T, above 95% for both of them, relatively high score for J, and 0.67% accuracy for N. If I didn't mention it before, these are the percents for correct guesses that I calculated in my R Markdown file. So these were really good scores, and I was very happy with this one. So when I try and do K and N on the category, so either saying this one is all, INTJ, ESFP, etc., it was only 0.13 for accuracy, which makes sense because it's going to be significantly harder to pick 1 out of 16 bins as opposed to 1 out of 2 for each. So the distribution actually mimicked the distribution of the training almost exactly. Very even matching with that, so I thought that was interesting. Next, I used a decision tree model, and the decision tree did something interesting, whereas for I, N, and J, it decided to put every test variable into whatever the most common thing was. So I is the most common first letter, so it decided to guess that every test observation had an I as the first character, and so on and so forth for I, N, and J. For T, it divided it almost in half, and it actually yielded pretty good results, relatively high. Still not higher than our K and N model, but just going with the mode is actually not a horrible way to predict the character values one by one. When I tried to do it all together, so classify everyone in their 4-character sequence, it actually just binned everyone into the most prevalent category, which was INFP, and it actually had a better success rate than the K and N model had. It had 0.2. So that, I think, goes to show how unlikely it is that any model could really correctly guess all 4 of these characters together due to the distribution and the amount of other options that there are. So overall, the decision tree could most accurately predict the 4-character value, and K and N was the most accurate predictor of the single character values because it had some very high accuracy results. So what does this mean? Finding correlation between all 4 characters is super, super hard. You have a way higher probability of an incorrect guess. There's a super low chance of matching to any of the underrepresented categories. It's way easier to predict single character variables as they are one-off. It's either one or another, and you can look at the data more closely. But how do we feel about this? Is this what we want? Is this a good indicator of your personality type? I say yes. So the MBTI character indicator is supposed to be comprised of 4 different letters that mean 4 different things. So it makes sense if one letter is more correlated to certain things than another letter is. It's less of a holistic item and more of a part-by-part item. So I think it's more meaningful if you can say with 99 and 96% accuracy that 2 of your variables are correct than say with 20% accuracy 4 of my variables are correct. Because if you know at least 2 are almost 100% correct, then you can go forward and try and derive more things from that.